In this subchapter, we will talk about a particular mechanism called the NAT, Network Address Translation. Faced with the scarcity of the IP version 4 addresses in the 90 years, a workaround was chosen that consists of putting private addresses in corporate networks and small office home office networks, and in the perimeter with the internet do NAT, that mechanism called network address translation. The NAT use, in fact, a range of addresses defined in the RFC 1918, that is 1918, and reserves in 3 net blocks for use on private networks. One net block is class A net block that use, in fact, the net number 10. That is, the net block is identified with the address base 10.0.0.0/8 bits of net mask. That is, in fact, this net block range from 10.0.0.0 and 10.255.255 and in fact it's one class A net number, only one, that is the net number 10. There are another net block that is reserved to be used on private networks, that is a class B net block, and that class B net block is defined by this address base 172.16.0.0/12, that is the range from 172.16.0.0 and to 172.32.255.255. In fact, then here in this net block we use 16 class B net numbers. The net number 172.16 .17.18 until 172.32. That is 16 class B net numbers. Finally, there are another net block reserved for use on private networks that is class C net block. The address base is 192.168.0.0 with a mask of 16 bits /16. That is, in fact, a range from 192.168.0.0 to 192.168.255.255. And then, in fact, this net block use, in fact, 256 class C net numbers, from the net number 192.168.0 to the net number 192.168.255. Then is a wide range of addresses that are reserved for use on private networks. Then what we need to understand clearly is that, in fact, if here we are the internet, that is a public network with public addresses. There are some addresses like those that in fact are not used within the internet, are for use only within private networks. And in fact, there is a network device, an intermediate device that connect the private network to the internet network, that is the private network to the public network. And is that device that need to implement that mechanism that we call NAT, Network Address Translation. Then NAT translates the source addresses of the datagrams going out to the internet. That is, if a datagram is sent from any host within that private network, and that datagram need to go out to the internet, in fact, we need the NAT mechanism to translate the source address of the host and to assign a public address to the source address of the datagram that will go out to the internet. And the NAT translate the destination address of the datagram going into the private network. When, for instance, a datagram comes from the internet and go into the private network, designated to a particular public address, but in fact directed to a host in this private network that in fact use a private address, then we need to translate the destination address of the datagram in order to reach the final destination within the private network. Then there are different types of network address translation mechanism. The most simple is one called one-to-one mapping. That is, when we associate always the same private address with the same public address, and this assignation is one-to-one, is a one-to-one mapping. In that case, it's very simple because always a datagram that go out from that private address to the internet. In that case, the NAT translates the source address of the private address to the source address of the public address. And in the same way, when the datagram comes from the internet, that is go into the private network and is destined to that particular public address, that particular public address in the destination address will be translated to the particular private address within the private network. But in this way, we only could offer the connection to the internet only for a few hosts within the private network. Then we need to implement another kind of or another type of network address translation mechanism in order to permit that all the hosts in this private network could exchange datagrams with internet. And in that case, we typically use another type of NAT called many-to-one mapping. That is, many private addresses use or share the one public address. For instance, it is typically used when any host with client processes in distributed application the client side of the distributed application is running on any host within the private network. But when those hosts send a datagram to the internet, the source address of the private source address will be translated to the same public subaddress that typically, for instance, in fact, is the external public interface of the firewall or router that connect the private to the internet, the private network to the internet. But in fact, when this is performed, we need to identify the flow of datagrams in the other way. For instance, if a particular host here send a datagram to a particular server in the internet, when the server in the internet answer to this host, we need to multiplex the possible responses to the appropriate different hosts within the private network, even if those hosts are identified with the same public address. And in that case, we will use the port numbers. And in that case, we use a mechanism called NAT, that is Network Address Port Translation. That is a mechanism that is also called hiding or masquerading NAT. Well, then remember, in the private network, we could assign addresses from those ranges defined in the RFC 1918. That is the addresses that use the net number 10 or the net number starting with 172.16 or the net numbers that start with 192.168 addresses. IP addresses from these branches, remember that those branches are not routed on the internet and are intended for internal use in private networks. And in fact, there is a source network address notation when the packet is going out to the internet, and a destination network address notation when the packet is going into the private network. In fact, and remember, we could have a different type of address translation, the one-to-one mapping, and the many-to-one, or that use, in fact, the mechanism called NAT or PAT, that is Network Address Port Translation or Port Address Translation. And here we could observe this illustration shows, in fact, this is the private network, and this is, in fact, the internet. This is the router of the internet service provider, typically in the premises of the client. And there is a connection, line connection between the firewall of the private network and the router of the internet service provider. And behind the firewall, there are a lot of switches and hosts within what we call the private network. For instance, in this private network, we use the range 10, the class A10, or the class C192.168, we need to perform the network address translation in this box that is typically a firewall. That is a router that performs some kind of packet filtering in order to protect this private network from attacks from the internet. Then, in this case, when, for instance, a client process in those hosts need to establish a communication with a server in the internet, and they will use a NAT translation, address translation mechanism that it will be performed here in the firewall. Remember that when the client is, if the client is inside of the private network, the client uses an ephemeral port, that is a port over 1024. And it's not important which is the ephemeral port used. What is important is that that ephemeral port permits the identification of the process, the destination process of data when the server sends it some message. Then, for instance, when this client establish a communication with a server in the internet, use typically, for instance, a port like this one, an ephemeral port. And when the datagram go out to the internet, this source address and this source port will be translated to this source address and this source port. And when another, for instance, client in another host use another port, another ephemeral port, in fact, in the firewall, this box will perform a NAT mechanism, translating the other ephemeral port inside the network, the private network, to another different ephemeral port, a public ephemeral port, and in that way we could multiplex and differentiate the traffic between different client side processes within the private network, and in that way we could we could enable the communication of several hosts within the private network with any server in the internet.